Hello everybody, my name is Sam Borms and I'm presenting to you today the R package sentometrics. Me and the co-developers, we also call it an integrated framework to construct time series based on textual sentiment and to use these time series for prediction. So the package is actually a combination of two fields. First of all, text mining, which can be deemed the way of collecting actionable insights from text. And the way we do it is by focusing on sentiment analysis. On the other hand, we also have econometrics, time series econometrics to be more precise, which is simply the analysis of data with data stems, typically in economic context. And we focus on the aggregation of sentiments to time series and then the use of these time series in prediction models. So if you fuse these two together, you have sentiment analysis and econometrics, and we have what we call sentometrics. And it's not only in our package, it's also a research effort by an increasing number of PhD students and professors at the University of Neuchâtel in Switzerland and the University of Brussels in Belgium. But now let's go for a walk in the park with the R package itself. First of all, you need data. Data are texts. We have built in a corpus of texts of US news articles in the package. It needs to be structured in this particular way with an ID column, a date column, a text column, and features column. Features can be anything that provide information on the text, for example, on events, on companies, or date periods. It can be anything. Next step is to make the corpus package ready. So we have a lot of sento functions. The first function, which is interesting, is a sento corpus function. You just plug it in, and then you can play around with it. There is the great text mining package, quantdata, which can be applied to this particular corpus structure of ours. And then you can also add some other features to make your corpus a bit more interesting, a bit more wider. Next up is about sentiment analysis itself. We focus currently only on lexicon-based sentiment analysis, which is not the most accurate method, but if you have a lot of text and you aggregate them, it's going to be pretty fine. So you have to select a few of word lists with words with a certain positive or negative polarity. Once again, we also have a few built-in of these word lists. You pick these, you plug these into another function, and then you're up for the most interesting step, which is the definition of how exactly you want the sentiment to be aggregated into time series. So you have a lot of scores per word, so you have to define how you want these scores to be merged into a score per document, how you want the scores for all range of documents be merged per date to obtain a time series, and how do you want to smooth the time series. So this is all defined in a control object, which can then very simply be plugged into another sento function, the sento measures function, which then does the magic, basically, so you obtain a lot of different sentiment time series across all the combinations of the lexicons, because you can supply multiple ones, features, and then the smoothing scheme. So you have a lot of different time series. That's already interesting, from a corpus to a lot of sentiment time series. You can plot these across the dimensions. You can see how it looks like. For example, you see on the right-hand side that some lexicon gives a particularly positive sentiment, another more negative. But that's only one part of the story. The other part of the story is to use these time series to do prediction. And as a case study, we want to try to predict 1 month ahead the economic policy uncertainty index. If you haven't heard about that, there is a nice website to explain how it looks like. And because we have a lot of these sentiment time series generated, we apply penalized regression, a very simple linear regression, but just with a lot of variables, potentially higher than your sample size. We use a GLMNet package to do this. There are, again, some specifications you have to define, but you have to apply the sento model function, the third in the series of 3, to just get your output. And in this case, we do just one function call, and you have a whole entire out-of-sample analysis. So this is nice. So there's a lot of model performance measures also in the object itself. But it's, of course, nicer to plot it out. And you see that for this particular case study, of course, otherwise it would not be presented. The performance out of sample is pretty good of our framework for this particular policy uncertainty index. A little add-on is the graph on the right-hand side, which decomposes the sentiment into underlying dimensions, in this case the features, so you could see at which point in time your prediction is made of and which type of features are most informative in some periods, for example, a crisis period. So there was a quick example of the package, Sentometrics. It's still in its early stages, but I suggest you to download it and to provide feedback. And we will continue to develop it. And if you're interested in modeling text based on sentiment and predicting some variables, we hope that this is a place you would like to go to. Thank you.